Hello everyone, I'm Snigdha Kakkad and this is my channel AccelerateAICareers. Today we are going to do a very interesting question, Leetcode53, Maximum SubArray. It has been asked in Amazon and Meta's interviews in last 6 to 12 months. It's a very interesting question. Let's see what does the question say. So you have been given an integer array nums and you have to find the subarray with the largest sum. And what do you need to return as an output? It's sum. Let's look at an example here, like -2, 1, -3, 4, -1, 2, 1, -5, 4. This is an array given to you, nums. And the output is 6, which is the maximum sum of the subarray. And what's the subarray they have chosen? It's this, 4, -1, 2, 1. The sum comes out to be 6. That's what they have chosen. So how did they find out? We'll look into all possible solutions and then we'll code the best one. So I'll walk you through that, but let's look at some other examples before. You have been given just one single input as nums array and the output is also 1 because there's only one possible combination. Now another thing you have been given is 5, 4, -1, 7, 8 and the output is 23 because if you sum all of them together, then it comes out to be 23 and it turns out to be the maximum sum. Now, as you would have noticed in all these examples that the integers could be positive, negative in the nums array. It need not be all positive, right? So since the integers could be positive or negative, the sum could vary, right? And you have to choose the one with the maximum sum and it should be contiguous. So it has been given that the subarray you choose should be contiguous, okay? So let's look at this first example. I have already pasted it here. So what is the brute force approach you could think of finding that particular maximum sum? So the brute force approach could be you would take first a subarray starting with -2. So one would be just -2 and sum is -2. Then you would consider next combination which is -2, 1 and the sum would be -1. And you would go so on -2, 1, -3 and so on till n-1. And you would find the sum of all the subarrays. Then you will exclude -2 and you will start your subarrays from 1. So just 1, then 1, -3, then 1, -3, 4 and so on. And that you will do till the end. So you will be considering all the possible subarrays, computing the sum and checking out whether that is a possible solution or not and updating the maximum sum. And finally, when you have run through the entire list of subarrays, at that time you return the maximum sum which you have found. But what would be the complexity for this? So if I just write the pseudo code for it, so for I in range, so the range would be say index 0, then index 1 till index n-1. So this would be your starting point for your sliding window which you are choosing for your subarray. Then your end point for your sliding window will also be from range I till so on till n-1, right? And finally, to calculate the sum for the subarray, you will use another loop which will range from I to j and you will check for all the possible sum between that window, right? And then finally you would compute sum. So this is your pseudocode, something like this. As you can see, the time complexity for this would turn out to be O of n cube, which is a lot, and you want to reduce it. So what could be a better approach? So this is not such a good approach. So what could be another approach you could use which can save you some time and some effort as well as reduce your time complexity? So then there comes in another possible solution where you save the current sum. So say suppose I consider this subarray -2 and I update my current sum variable as -2. Then I consider this subarray -2, 1 and the sum is -1. And I'll compare it with current sum and update the current sum. If you see, another thing which I can take to reduce the time complexity is if I consider a subarray starting from -2, then this is just this. If I consider another subarray, then this. Then another subarray, then it's this. And so on. So basically, whenever I consider a new subarray starting with -2, I'm just adding nums j there. Rest of the sum has already been computed before, which has been stored in current sum. So let me keep my current sum as is and just update it by adding num j. So how will the code update? So instead of this for k loop, I will just have this compute sum. And how will the sum be computed? This sum will be computed by current sum plus nums of j. This will reduce my time complexity from on cube to on square. This is good enough approach, but again, it's still more complex. The time complexity is still on square. So can I do better than this? If you look at this array, do you really think that I need to calculate the sum of each subarray considering they start from negative values as well? Like -2, then -2, 1 or -3, 4. Do I need to consider even these subarrays? So the answer is no, because what you are trying to achieve is you need to get the maximum sum. And negative values are not contributing to maximum sum. What they are doing is they are in fact reducing your sum. So that's the notion behind your most optimized solution, which I'm going to show you here. So what I'm going to do, I'm going to consider if the prefix, which the number which I'm considering like nums j, if the prefix before that is negative or positive. If the prefix is negative, I will just set my current sum to 0 again, because I don't need that negative prefix, right? It's not contributing to my maximum sum. And that is the crux of my solution here. So what I'm going to do, suppose I start with -2. So the current sum would be -2 here, right? It would be -2. And I have saved it here. Now go to the next value, -2, 1. In that case, when I'm considering this, my current sum gets updated to -1, right? But if you know -2, 1, we can just disregard this prefix because it is negative. We don't need to consider that subarray. So we can just get rid of it. So my current sum can be set to 0, and then I can just add this 1 there. Because the negative prefix can be ignored, it will not contribute to maximum sum. So now my current sum is positive. Now let me consider 1, -3. In that case, that overall sum turns out to be -2. So let me save it as -2 here. Let me consider 1, -3, 4. So the prefix here is -2. The sum of 1 minus 3 is -2, which is negative. So I don't need to consider it. I can get rid of it because it's negative, and I can update my current sum to 0 again and add just nums j, which is 4 there. So I can consider that as a starting point. Now, considering 4, -1, my prefix will turn out, my current sum will turn out to be 3, which is positive. So let's go ahead. Considering 4, -1, 2. So my current sum will get updated from 3 to 5. Since the prefix was positive, I didn't get rid of it. After extending 4, -1, 2, 1. So my current sum for this is 5, which is positive. So I can just add the next value and my current sum will get updated. Now let's consider the next value, -5. So the prefix is positive 6, so I need not reject it, and 6 minus 5 turns out to be 1. So your maximum sum is still updated to be 6, and your current sum gets updated to be 1 because it was 6 here, and when you added -5, so it would be 6 minus 5, which is 1, right? Now if you want to consider this 4 also, in that case your prefix is positive, which is 1, so you cannot discard it. And you have 4, so you would add it and current sum will tend to be 5. But still your maximum sum value, which was 6, for this subset 4, -1, 2, 1 is still the max. So you can return this value safely. This is the crux of the solution. What you do is you check for the prefix of the current number you are considering. If the prefix is negative, you get rid of it. You don't need it in your subarray. If the prefix is positive, you consider it and add the current value to it. If the prefix is negative, how to get rid of it? You set your current sum back to 0 rather than considering negative, and then add the current value to it, nums j to it. That's your solution. So let's start coding. Maybe that will explain you better what I'm doing. So first of all, I will initialize max sum, and I have to initialize max sum with something, right? I cannot initialize it with 0 because max sum would be a part of this array. It cannot be 0. So let me initialize max sum as the 0th index value of nums array. After this, after initializing, I'll initialize current sum, which is 0 initially when I'm started. Now I will loop through the nums array. For each number in nums, I will check if current sum is negative. That is my base case. So if my current sum is negative, what do? I set current sum equal to 0. So I will add current sum plus current value. And what is the current value? It's nums j or n. Okay, so I have added that value. After that, I will update max sum. And what would be my max sum? My max sum would be max of max and cur sum. So I will check if current sum is greater than max sum and then save it in the max sum. If it is not greater, then I'll retain maximum sum. And finally, once it has looped through the entire nums array, I will return max sum. So that is the entire code. The coding was not the tough part. Understanding how to get the optimized solution is the most important part of this question. Let me summarize the solution for you. So we initialized max sum with the first value in the nums array. We initialized the current sum with 0, and then we looped through the nums array. Then we proposed our base case. If the current sum is negative, in that case, reset current sum to 0, and finally add current value, that is n, to current sum. Okay. And then check if current sum has gotten greater than max sum. If yes, then replace it in max sum. If not, then retain max sum. And finally return max sum once you have looped through the entire nums array. So that is it. Let me run and show it to you. So it's accepted. Let's submit. So do you see the solution is this good? So I hope you liked my way of solving problems. If yes, then subscribe to my channel to get your daily LeetCode challenge videos. Let me know if there is any other question you would prefer for me to prioritize and solve. I would be happy to jump on it. If you have any doubts, any questions regarding the question, mention it in the comments. I'll be happy to address it. Thank you.